In this video, I am going to give you a simple introduction on how to write the electron configuration of an element. So let me first discuss what is electron configuration. Electron configuration means the distribution of electrons of an atom in different sublevels or orbitals. Let's talk about chlorine. You know that the atomic number of chlorine is 17. This means that chlorine has 17 proton and 17 electrons, right? So we need to distribute the 17 electrons of chlorine in different sublevel. So in first energy level, we have just one sublevel which we can write 1s. In second energy shell, we have two sublevel, that is 2s 2p. In third sublevel, 3p 3d, 3p 3s 3p 3d. That is in the third energy level we have three sublevel, right? And in the fourth energy level we have four sublevel. Right? You know that in S sublevel we can write maximum 2 electrons, that is S sublevel can hold 2 electrons, P sublevel can hold 6 electrons, and D sublevel can hold at maximum 10 electrons, and F sublevel can hold maximum 14 electrons. Actually, I will show you two methods to write electron configuration of an element. I think the second method will be very attractive to you. So to write the electron configuration of chlorine, now you have to draw a line like this. So 1s2, then you have to consider this 2s2, then this 2p6 and 3s2. So count 2, 4, 10, 12, right? 12. We need more. Like this. 3p, 12 plus 5. P can hold maximum 6, but we have more 5 electrons to distribute, so we can place here 5. So this is the electron configuration of chlorine, right? Let me write the another method, or let me show the another method for writing the electron configuration of chlorine. Okay, so let us delete this. Okay, to show you the second method, you have to memorize this. SS just once, PS just twice, then DPS just twice, SS 1, PS twice, DPS twice, then you can take FDPS, right? That is, you can take any number of FDPS according to your need, right? So now look, you have 17 electrons, so you know that S subshell can hold maximum 2, P subshell can hold maximum 6, D subshell can hold maximum 10, and F subshell can hold maximum 14. So let us distribute 2, 4, 6, that is 10, 12, then 17. So already we have distributed 17 electrons that chlorine have. So we don't need this sub-level, right? Since we have covered 17 electrons. Now our task is to place the principal quantum number value, right? That is why look, S sub-level start from 1s, then 2s, then 3s, right? Thus continue. P sub-level start from twice P, 3P, 4P, and thus continue. And D sub-level comes in 3D, 4D, 5D, and thus continue. And F sub-level start with 4F, right? 4F, then 5F, 6F, and continue. You have to remember this. S start from 1S, P start from twice P, D start from 3D, and F start from 4F. So let us place the number before all S, 1S, 2S, 3S. Then P start with twice P, then 3P. So this is the electron configuration of chlorine. Okay. Now write the electron configuration of chloride ion. If I place here one negative, then this is chloride ion. So in chloride ion, how many electrons you are getting? Look, the atomic number of chlorine is 17. That is, it has 17 electrons, but for negative charge you have to add more electrons. So you have 18 electrons in chloride ion. So you have to distribute that. So you have to write like this: SS, then PS, then DPS, then FDPS, and this will continue. FD, you can take any times of FDPS according to your need. So let us distribute these 18 electrons. 2, 4, 10, 12, 12 plus 6, 18. So you don't need this sub-level, right? Now place the value of principal quantum number. So let us place the number before S, 1S, 2S, 3S. Okay, there is no S. Then P, 2P, 3P. So in this method you can quickly write the electron configuration of any atom, ion or ion, right? So now let us consider the atom aluminum, right? Aluminum 13. So how to write? So look, let me show you the first method. 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, right? So aluminum has 13 electrons. So let us put 1s2, then 2s2, then 2p, 6, 8, 10, then 3s2, 12, then 3p, 1, right? So 2, 4, 10, 12, 13. So this is the electron configuration of aluminum. You can write the electron configuration of aluminum by the second method that I am going to show you, right? Okay. To write the electron configuration of aluminum in second method, so write the sequence SS, PS, PS, then DPS, DPS, then FDPS. You can take any number of FDPS. So let us distribute 13, 2, 4, 6, 10, 12, 13. So you don't need these sub levels, right? So now number the S sub level: 1s, 2s, 3s, then P start with twice P, then 3P. So this is the electron configuration of aluminum. Okay, now talk about the nitrogen atom. Its atomic number is 7. You can place atomic number here or here, right? So this is the first method. Three D, 4s, 4p, 4t. Start with 1s, 1s2, then 2s2, then 2p, 3. We can we can place maximum 6, right? In S we can place maximum 2, in P we can place 6, and in D we can place maximum 10, and in 4F we can place maximum 14, right? So look, already we have used all our electrons that are available in neutral nitrogen atom, 7, right? This is the first method for writing the electron configuration of nitrogen. Now let me show you the second method. In second method, you have to, at first you have to write the sequence of the subshell: SS, PS, PS, then DPS, DPS, then FDPS, and this will continue. So let us distribute 2, 2, 3. 2 to 4, 3. So you don't need these sub levels. Now place the value of principal quantum number before S and P. So S start with 1s, then 2s, and P start with 2p, right? So that this is the electron configuration of nitrogen. Okay, now let us write the electron configuration of iron. Iron is 26. So how to do that? Look, at first 26 electron, so 1s, 2, then 2s, 2, then 2p, 6, then 3s, 2, right? 3s, 2. Now count 2, 4, 6, 10, 12. After 3s, then we have to place electron to 3p, 3p, 6, 8, 10, right? Then after 3p we have to place electron to 4s, 4s, 2, that is 20. After 4s we have to place electron to 3d, right? 3d, 3d, how many? We have 6, right? 6. So this is the electron configuration of iron, right? So let me show you the second method to write the electron configuration of iron. Okay, so write the sequence SS, PS, PS just twice, then DPS twice, DPS, DPS twice, then FDPS, FDPS. You can take any number, any times FDPS. Continue. So let us distribute 26, 2, 4, 10, 12, 12 plus 6, 18, 20, 20 plus 6, 26. So already we have distributed all the electrons. So we don't need this sub-level. Now let us number. S start with 1s, then 2s, then 3s, then 4s, right? P start with 2p, then 3p, and D start with 3d, right? From 3d. So this is the electron configuration of iron. So what is the electron configuration of iron 2 plus? So iron has 26 electron, but due to plus, that is you have now 24 electrons, right? So to write the electron configuration of ion, you have to write the electron configuration of the neutral atom, right? So at first you have to in neutral atom we have 26 electrons, and the electron configuration of a neutral iron is this. Now you have to adjust 2 electrons, that is you have to deduct 2 electrons from the neutral atom. So from where you will deduct that 2 electrons? You have to deduct that 2 electrons from the outermost shell, right? So look, here the outermost shell is the 4s, right? Because the n value here is 4, and for here n value is 3. So the outermost shell is 4s, right? So for 2 plus, the 2 electrons will come from the outermost shell, that is from here, right? So the electron configuration of iron 2 plus is this, right? Okay, now talk about the electron configuration of chromium. 24. Actually chromium shows something different, right? Look, we'll write this sequence SS, PS, PS. Okay, look, SS, PS, PS, GPS, GPS, right? Then I can write FDPS. Okay, let us distribute this 24 electrons. 2, 4, 10, 12, 18, 20, then 24. So already we have distributed all the electrons that are available in a neutral chromium ion. So let us number this sub-level. 1s, S start with 1s, 1s, 2s, 3s, 4s, right? P sub-level start with second sub-level, twice P, 3p, right? And the sub-level start from third energy level, 3d. So this should be the electron configuration of chromium, but look here, the outermost shell is 4s, is 4, right? And here look, and the sublevel immediate before the outermost shell is 3, that is 3d, right? So you know that s orbital, s sublevel can take maximum 2, right? And the half of 2 is 1. P sublevel can take maximum 6, thus half of 6 is 3. D sublevel can take maximum 10, the half of 10 equal to 5. F sublevel can take maximum 14, the half of 14 is 7. Half filled sublevel or orbital and full filled sublevel or orbital is more stable, right? So here D has 4, but the stable form of D is 5. So easily it will take 1 electron from the outermost shell, that is it will take 1 electron borrow from 4s and it will make D5. Right? So when you will get D4, then you have to make D5. When you will get D10, D9, sorry, you have to make D10, because this electron configuration is stable, right? So chromium is the exceptional example you can think. I hope, believe and expect that now you are capable to write the electron configuration of all the elements.